Okay, this is IGCSE Edexcel. Okay, GCSE Edexcel, and this is paper 2CR. Okay, January 2021. So, substances can exist as solids, liquids, or gases. Give the change of state that occurs when a substance melts. Okay, so of course, it changes from solid to liquid. It changes from solid to liquid. Okay. Complete the word equation for the sublimation of iodine. So of course, sublimation means when the thing changes from solid to gas directly. The circle in the diagram represents a particle. Give complete the diagram to show the arrangement of particles in a gas. So gas ke particles, of course, they are far away from each other. Okay, just like that. There is a gap between the particles of gases as compared to liquids and solids. Okay, and they are more random as compared to liquids and gases. The table lists some substances about particles, place ticks and boxes to show which two statements are correct for water particles. Particles only vibrate, no. Water is a liquid. Okay, water is a liquid, it's wrong. Then they are saying that the particles do not move, no. The particles can move, okay, because this is a gas. Because this is a gas, oh sorry, like water is a liquid, so the particles can move from one place to another place, okay. Um, the particles have no gaps. No, it's a liquid. It has a gap. The particles move randomly. Yes. The particles have more energy than in ice. Of course, yes. The particles have a regular. No. Okay, because it's a liquid. And this question is about elements in group 7 and their compounds. So predict the color of fluorine at room temperature. Yellow. Yellow. I should say it's pale yellow. Pale yellow. Okay, pale yellow. How many of the elements in the table are liquids at room temperature? 20 degrees Celsius. Okay. So means that I can say like they were asking liquids at room temperature. Okay. They are asking liquids at room temperature. So of course this is solid and the boiling point is greater than 20. So of course I can say that bromine is liquid at room temperature and this is below 20. So of course this should be a gas. Okay. So bromine is liquid. Of course B is your correct option. The element astatine is below iodine in group 7. Predict the formula of a molecule of astatine. Of course, it's AT2, astatine. Just like Br2, Cl2, F2, I2. So this is AT2, the same thing. Okay. Okay, Abdullah. So seawater contains bromide ions. Bromine can be obtained by bubbling chlorine through a sample of seawater. The ionic equation for the reaction is this. Explain which species acts as an oxidizing agent. Oxidizing agent is the one. Oxidizing agent is the one which reduces itself. Oxidizing agent is the one which reduces itself. I can say that. And reduction is gain of electron. Who is gaining electron? Chlorine is gaining electron. So means that chlorine is going to reduce. So chlorine is an oxidizing agent. Cl2 is an oxidizing agent. Cl2 is an oxidizing agent as it is reduced from 0 to -1. Okay. The reaction occurs because chlorine is more reactive than bromine. Bromine is below chlorine in group 7. Explain the decrease in reactivity from chlorine to bromine. So the size of an element increases. Size of an element is going to increase. Okay, increases as the number of as the number of shell as the number of shell increases, so the distance I can say like the nuclear attraction decreases. So I can say Nuclear attraction decreases. Nuclear attraction decreases. Ability to attract electron. Ability to attract electron decreases. Okay. Ability to attract electron decreases. So reactivity decreases because they are non-metals. They are non-metals. Non-metals have to gain electron. If they are gaining electron easily, if they are gaining electron easily, so the metal is more reactive. And if the non-metal is not going to gain electron easily, so that non-metal is less reactive. Okay, of course, if you are going down the group, what does it mean? Size increases, ability to attract electron decreases. That's why I can say that like their reactivity decreases, and the reactivity of metal is just reciprocal of that of non-metal. Okay, so you must know this. Elements in group 7 react with elements in group 1 to form ionic compound, of course. Metal reacts with non-metal, of course. So uh, which pair of ions both have the electronic configuration 2 comma 8 comma 8? So the total electrons are 18. Okay, so lithium is incorrect because its proton number is 3. How is that possible? uh, Potassium is good because it's going to have 18 electrons because the proton number for potassium is 19. Positive means it has given one electron, of course. And you can say that fluorine is going to have 9. That is, it's going to gain one more electron to give 10. So it's incorrect. They are saying both ions. It's incorrect. It's lithium. It should be correct because potassium is 19. So 19 minus 1 is 18. Cl is 17. 17 plus 1 is 18. So D is your correct option. Explain why metals conduct electricity but covalent compounds that do not conduct electricity. You know, um, metals have a giant metallic lattice structure, and they are going to have extra electrons, free delocalized electrons. Okay. And if you talk about covalent compounds, so they are neutral molecules. There is no charge on covalent molecules, and you can say that electrons are not free to move. Okay, of course, electrons are not free to move. There is no delocalized electrons. So we can say that the covalent compounds would not be conducting electricity, would not be containing conducting electricity. Okay. So this is of 4 marks, of course. So I can say that metals have free electrons, or I can say it has delocalized electrons. Okay. And covalent compounds covalent compounds do not contain ions, okay, that can move, okay, that can move. So that's why, okay, and you can say that, okay. Hydrogen chloride is a covalent substance. When hydrogen chloride is added to water, a solution of dilute hydrochloric acid is formed. This solution does conduct electricity. Okay. Name the type of particle in the solution of the dilute hydrochloric acid that allows it to conduct electricity. Okay, ions, 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 because it's not a metal. When it would be asking for a metal, so you can write electron, but they are asking about the compound. That is a covalent compound. So it's a polar covalent compound, H positive and Cl negative. So they would be moving freely. They would be moving freely, and of course, they would be a good conductor of electricity. Okay, so I can write ions. In C, they are saying that the teacher uses this apparatus to investigate the electrolysis of a solution of dilute hydrochloric acid. The M meter, okay, 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 okay. Uh, the teacher repeats the experiment several using a different current each time. The teacher wants to find out if there is a relationship between current and volume of gas collected at each electrode. Okay. The table gives the teacher's result for syringe Y. Plot the results. Plot the results for syringe Y. Acha ji. I am plotting the results. Okay. Point one. Point one. Then 8. This is point one. Then this is 8. This is my first point. This is my first point. And and 15 and 0.2. 0.2 and 15. Okay. 3, 22, 22, 20. 15. Oh my God, it is 15. 15 is there. And then 0.425. 0.425 is this. Okay. 0.537. 0.537. 35, 37. Okay. Then 0.644. 0.640, 40, 40, 44. Then 0.752. Then 0.752. 0.751 and then 52. Then 0.860. Then 0.860. 0.860. Okay, okay. Plot the result. Draw a circle around the anomalous result. Of course, this is anomalous. This is anomalous. Anomalous, anomalous, anomalous. Uh-huh. Okay. Explain a possible cause of the anomalous result other than misreading the apparatus. Okay. Uh, so should pass from origin, of course. Oh my God. This is origin. Explain a possible. Okay. So you can say that um, it should be over there. Expected is this. It is a larger volume. It's a less amount of volume. Okay. So the reading is less than expected, of course. We are getting the less amount of volume. And this is your current, of course. Okay. You can say that when you were providing a current that is of zero point 0.4 ampere, of course, it's directly proportional to the volume of gas. More current is passed, you would be getting the more volume. But I'm not getting expected volume. I'm getting less than expected. Why? What's the reason? Maybe it's maybe there is a leak. Maybe, of course, it's possible. Maybe there is a leak. There is a leakage, of course. Gases are going to escape from the container. It's of 2 marks. It's of 2 marks. I can say that volume volume is less than expected, okay, as some escaped from the container due to leakage. Due to leakage. Okay. Deduce the relationship between current and volume of gas collected in syringe Y. Relationship. Relationship you have to tell. So of course, directly proportional. The ionic equation, okay, suggest how these ionic half equations show that the volume of chlorine collected in gas syringe should be the same as the volume of hydrogen collected in syringe Y. So, you know, uh, you can see that uh, in equation 1, the two electrons are released, and in equation 2, two electrons are gained. Of course. Okay. So, in this 1 mole of chlorine gas is observed, and in this 1 mole of hydrogen gas is observed. So, just how these ionic equations show that the volume of chlorine collected in gas syringe X should be the same as the volume of hydrogen collected in syringe Y. It's very easy. It's a baby question. It's a baby question. It's a baby question. So I can say that it's of only 1 mark. Same number of moles of chlorine and hydrogen gas formed. Okay, very simple. Suggest why the volume of chlorine collected in gas in syringe X is always less than the volume of hydrogen collected in syringe Y. Hmm? Mhm. So the thing is that why the volume of chlorine in syringe X is always less than the volume of hydrogen collected in syringe Y. You know, chlorine is soluble in water, hydrogen is not. So chlorine dissolves. That's the reason you would be getting the less amount of volume than expected. It would dissolve. Complete the table by giving the missing information. Okay. So the relative formula mass is, of course, we have 2 carbon, 12 multiplied by 2 plus 5 plus 16 plus 1, that is 46. 74. So it's C4H9, it's butanol. Ethanol can be oxidized to ethanoic acid by heating with potassium dichromate and another reagent. Name the other reagent. Of course, we can use acid as a catalyst. That is sulfuric acid. State the color change that occurs during this reaction. Color change. Abdullah, color change याद रखने हैं तुम्हें लाजमी, okay? So you know the color of potassium dichromate, what's the color? It's orange. And after the reaction, it turns into green. It's orange. It's orange to green. Alcohols react with carboxylic acids to form esters. Name the ester that formed when ethanol. Ethanol means ethyl Ethanoic acid means ethanoate. Means ethanoate. Complete the equation for the reaction between methanol and ethanoic acid. So this is ethanoic acid. This is ethanoic acid. Okay, so that would be CH3 COO CH3. Okay, this is your ester. A catalyst increases the rate. State one other property of a catalyst. State one other property of a catalyst. So it's chemically unchanged. It doesn't take part in a chemical reaction. Okay, it's chemically unchanged, right? Oh my God, what's happening? Okay, I would write later on. I can't write right now. A student has the samples of three solids X, Y, and Z. The student uses this apparatus to find out. Okay. Describe the method that the student should use to find out which solid act as a catalyst. Okay, or basically hydrogen peroxide solution है. Okay, student has samples of three solids, and you can see that the student uses the apparatus to find out which solids act as a catalyst in the decomposition of hydrogen peroxide solution. Of course, catalyst would be increasing the rate of reaction. In the presence of catalyst, you would be getting more amount of gas, Okay. So, so in the first step, I can say that start experiment. Start experiment that is H2O2. Okay. And measure time. Okay. Okay. Then, uh, okay. Or, and you have to take the known amount of H2O2. Okay. Start experiment that is decompose H2O2. So I'm supposed to add some word over there that, okay. And you know what you have to do? Then repeat experiment with the same volume. Half H2O2, but with known mass, which are catalysts. Then measure the time. of gas produced. Okay. Volume of gas produced. Hmm? Okay. Of course, you have mixed the catalyst that was solid. And after the reaction, after completing reaction, separate by filtration. By what? By filtration. Okay. Then you know what you have to do? Then find the mass of and Z. And notice if there is change in mass. If there is change in mass. Okay. Then compare the time of collecting gas in both experiment. Okay. If there is increase in volume of gas with X, Y, and Z, so simple. Okay. The decomposition of hydrogen peroxide solution is exothermic. Okay. On the diagram, draw and label the reaction without catalyst, and with catalyst. So you know what we have to do? First of all, I would do this. First of all, I would do this. And then I would do this. So this is without catalyst and this is with. Sorry, this is without catalyst because activation energy is higher. And when the activation energy is lower, so I have used a catalyst. So this is with catalyst. Okay, simple. Use this information to calculate the total amount of energy needed. Means that you have to calculate the bond energy for the reactant side. So OH, then OO, then OH. How many bonds of OH we have? Four, two bonds. 463 times 2, then plus OO 146. Multiplied this by 2 because coefficient is 2. Okay, okay. Uh, Then it would be 2144. Use this information to calculate the total amount of energy released, means they're asking about the product side. So. Okay. Mhm. Moles of H2O are formed. Okay, so means OH. We have 463 times 4. 463 times 4, that is 18552. Then, of course, delta H is equal to reactant minus product. Reactant was 2144. Delta H is given to you, that is minus 204. And product is 1852 plus this is X. That is we have to find out. Okay. I have done each and every step. You would be solving this question and then you would be getting 496. Okay. Solve this question, then do let me know. Okay. Name the piece of apparatus that students should use to add the potassium hydroxide solution. Okay. How much potassium hydroxide you are supposed to add? 25.0 accurate volume. So you should use pipette. You should use pipette. What is the color of the methyl orange in an alkaline solution? You are supposed to memorize the color. You are supposed to memorize the color because this is yellow in alkaline solution. Okay. Concordant results are those within 2.2 cm cube of each other. Place ticks in the table to show which results are concordant. So, of course, I would say that 0.65, 0.60, and 0.55. The difference is zero point 0.5, so they are concordant. Okay, they are concordant. Use the concordant results to calculate the mean volume of acid added. So I would be adding them together and then dividing by the total number. That is 3. It's very simple. So I would be getting this. Okay, simple. Calculate the amount in moles of KOH in 25. Okay. So they're asking the moles of KOH. So mole is equal to, are they given the mass or something else? They have given you the concentration, that is 0.0370 mole per decimeter cube. Okay. And volume of potassium hydroxide, that is 25. Let's go change it into the dm cube by dividing with 1000. Okay, you would be getting the moles. You would be getting the moles. How many moles you would be having? Huh? Huh? How many moles you would be having? Yes. So this is of 2 marks only. So the answer is 0.000925 mole. Okay. Calculate the amount in moles of H2SO4. What's the mole ratio? 1 is to 2. 1 is to 2. This 2 is for potassium hydroxide and this one is for the sulfuric acid. I know the moles of KOH. So KOH is this. This is X. This is X. So what would be the mole? No. This is of 1 mark only. This is of 1 mark only. Okay. So you have to divide it by 2 to get the moles for sulfuric acid. Okay. I think so it would be this. Then they are asking concentration that should be in mole per dm cube. Moles are 0.0004625. And of course, the volume. Volume of sulfuric acid, that is this. Convert this in dm cube. I'm going to divide it by 1000. So I would be getting answer in dm cube. Okay, so that's the answer. In moles per decimeter cube. Okay. Now they are saying calculate the amount in moles of hydrocarbon X in the sample. So first of all, you know what we have to do? They have given you the volume of that hydrocarbon. So 600 centimeter cube divided by 24,000 is going to give you the moles. That is 0.025. Okay. The mass of the sample, the mass of the sample of hydrocarbon X is 1.45. Show the relative molecular mass of X is 58. X is 58. So, of course, mass is 1.45 grams. Okay, mass is 1.45 grams, or we know the moles that are this. We know the moles that are this. Basically, they are asking the MR or AR. MR is equal to mass over mole. So I got the mass. I got the mass. That is 1.45. And in the previous option, I was getting the moles. That was 0.025. That is this. So automatically you would see MR. You would see MR that is 58. Hydrocarbon X is an alkane. Show that the molecular formula of X is C4H10. So this is CH. Okay, C and H. And they are asking this is of only 1 mark. Show that the molecular formula of X is C4H10. Okay. So this is 58, right? This is 58. This is 58. So 4 into 12, then 10 into 1 would be equal to 58. Would be equal to 58. That's it. Because this is an alkane, the formula is CnH2n plus 2. Okay, so N means the number of carbon atoms. That is 4 in this case. Give the displayed formula of the branch chain isomer of hydrocarbon X. X has 4 carbon atoms. I'm going to make a branch over there, just like that. This is the displayed formula. This is the displayed formula. Okay, simple. This question is about ammonia gas. Give a chemical equation for this reaction. Ammonia can be prepared in the laboratory from the reaction between ammonium chloride and sodium hydroxide. So sodium chloride would be produced, ammonia gas. Along with that, the water is also produced. Okay. Then give a test for ammonia gas. Temp turns blue. In a sealed container, the reaction can reach a position of dynamic equilibrium. Explain the meaning of the term dynamic equilibrium. So, the rate of Concentration doesn't change. In a dynamic equilibrium, okay, once the equilibrium is established, so the rate at which the reactant is going to change into the product would be the same as the product is going to change back into the reactant. The concentration remain changed, but the rate of forward reaction is equal to the rate of backward reaction. Okay. The graph shows the percentage yield of ammonia at equilibrium for different temperatures and pressures. Using the graph, explain if the forward reaction is exo or endo. If you are going to decrease the temperature, you can see that higher than lower, that you are decreasing the temperature and the amount of product increases. I told you when I was teaching you the Le Chatelier principle, which explain that for the exothermic reaction, if you are going to increase the temperature, so the reaction moves backward because exothermic wants to release temperature. You are increasing the temperature, you are going against that of that reaction. So I can say that the reaction is exothermic. How? Can you justify this? Can you justify this? An amount of product increases. Okay, that's all about that paper. See you in the next class. Thank you.